So in your new book, you write, an animal can be read as a book about past worlds. What do you mean by that?
A biologist of the future should be able to read the animal and reconstruct the world in which its ancestors survived. As in the case of a camouflaged animal, you can read it literally on the back of the animal. That same principle must apply right the way through every bit of the animal. It must pervade every cell of the animal, every minute little biochemical process of the animal must say something about the environment in which it was naturally selected. It can't be done yet, and my book is an attempt to appeal to zoologists to start thinking in these terms, because I think that a zoologist of the future will be able to do that. I call her SOF, Scientist of the Future, SOF.
Philosopher Daniel Dennett declared that Darwin's evolution by natural selection was the greatest idea anybody ever had.
Great minds like Newton, who could have thought of it, Galileo, who could have thought of it, Hume, who could have thought of it, just never gave it a second thought, never even got close to it. Maybe the reason nobody thought of it is that it just is so powerful that people couldn't believe that anything so simple could explain all of life. It had to be God. If you could measure the power of a theory as a ratio of everything that it explains on the top of the line, and then what it needs to assume in order to do the explaining underneath. And what natural selection explains is everything about life.
Hello, Dallas. How are y'all doing? Okay, so let's get right to it. Let's not waste time. Please join me in welcoming on the first event of what is likely his final tour, Richard Dawkins. Thank you for being here, Richard.
Thank you.
So in your new book, you write, an animal can be read as a book about past worlds. What do you mean by that?
Any animal, and that includes us, is a product of natural selection, which has shaped it to survive and reproduce. And each of the ancestors of this animal has been shaped in a different world, way in the past. My thesis is that because of that, in principle, the animal can be read as a description of the worlds in which its ancestors survived, going way back to the millions of years, hundreds of millions of years back, and then coming on to near the present and including the present. It has to be a palimpsest. A palimpsest is a manuscript which has been reused. In the days before paper was readily available, people used to write on parchment, and then they would erase or partially erase the parchment and use it again. That's a palimpsest. So the book, which is the animal, must be a palimpsest, because it is the description from ancient times and more recent times and more recent times and so on, superimposed on it. But in principle, a biologist of the future should be able to read the animal and reconstruct the world in which its ancestors survived. It can't be done yet. And my book is an attempt to appeal to zoologists to start thinking in these terms, because I think that a zoologist of the future will be able to do that. I call her SOF, Scientist of the Future, SOF. It kind of resonates with sophisticated and sophisms kind of thing. So it's a call to the future, and it's, well, as you said, Coleman, this is my swan song as a tour, but it's not my swan song with the book. I may have more books, but this is a kind of rounding off of my major scientific books.
Okay, so your thesis could seem abstract to someone hearing it for the first time, but in the book, you helpfully have many beautiful illustrations that make it vivid. So perhaps it's worth putting one of these images in the audience's mind in case they haven't yet read the book, which you can buy in the front if you haven't bought already. You have a beautiful illustration of an owl in chapter 2.
Right.
I forget the specific species, but it blends in nearly perfectly with a certain tree.
Yes.
And the idea is, at least it seems to me, correct me if I'm wrong, that we don't exactly know the color of the trees of the environment of this owl, say 5,000 years ago, but we actually can infer the specific color of the tree by the assumption that the owl must have blended into it, right?
Exactly, that's right. The first 2 chapters really are about camouflage, and the owl is a very good example of a camouflaged animal, because a camouflaged animal almost literally has its ancestral background painted on it. Mm-hmm. The owl looks exactly like the tree bark that it's sitting in. The first of the illustrations is a lizard, a desert lizard from the Mojave Desert. And it seems to have sand and stones painted on its back. And all these other camouflaged animals, including the owl, appear to have their environment, or rather their ancestral environment, painted on their back. My thesis is that although that's obvious in the case of a camouflaged animal, the environment really is, you can read it literally on the back of the animal. That same principle must apply right the way through every bit of the animal. It's not reasonable to suppose that it would be only skin deep. It's not reasonable to suppose that this perfection of environmental imprinting on the animal should be limited to the skin. It must pervade every cell of the animal, every minute little biochemical process of the animal must say something about the environment in which it was naturally selected.
So is this thesis a restatement of anything in your previous books, or is it a reframing? What are you trying to do by phrasing it this way?
It's really all my books, in a way, are reframing of Darwinism. So these are just different ways of looking at the Darwinian principle, which is the brilliant idea that Darwin had to explain all of life. And all I've really done in The Selfish Gene, in The Extended Phenotype, and my other books, is to look at it in a slightly unfamiliar way, which may help people to understand it in ways that I like to think that Darwin would have enjoyed as well, actually.
Yeah, I mean, evolution it's one of these scientific theories that is so superficially simple, by which I mean, I remember where I was when I learned what evolution by natural selection was. I was in 7th grade in Miss Salente's biology class. And she explained using, because you grow up hearing the word evolution, at least if you grow up in the West or in Europe, it's on your tongue by the time you're 5, you've heard it, but you don't really know what it is. And the child's assumption is that the giraffe got its long neck because it reached and then it had a kid, and somehow that kid knew that it needed to reach higher because mom and dad tried hard. And so I entered 7th grade, and Miss Salente explained to me that actually, no, it's something different. This is how
it's very different.
It's very different. Yeah. But the reason I remember it so vividly is because, and your books all have this quality, is that when a beautiful explanation is given to you, it seems like it's obvious the moment you've heard it. The moment I heard what evolution by natural selection was, I thought, how could it possibly work any other way, right?
That's great. I mean, not everybody has that reaction. I didn't. T.H. Huxley, who was Darwin's friend and so-called Darwin's bulldog, he used almost exactly the same words. He closed the book, The Origin of Species, and he said, "How extremely stupid of me not to have thought of that."
Yeah.
And I must say, I think it's astonishing that it did take so long it took till the middle of the 19th century for anybody to think of it. And all these brilliant, clever people in centuries before who could have thought of it, because you don't need powerful mathematics, you don't need apparatus. It was independently discovered by Darwin and Wallace, both of whom were traveling naturalists. They were explorers. They went abroad and they collected specimens. They were not great philosophers, not by conventional standards. They were not mathematicians. And it's amazing that such a powerful idea could have evaded people for all those centuries and then finally occurred to two men in the 90s, actually possibly three. There's a good claim that a man called Patrick Matthew thought of it first. He was a cultivator of apple trees and pear trees in Scotland. And he sort of had the idea, but he didn't get the importance of it. He published it in the appendix to a book about naval timber. And just as a sort of afterthought.
Oh, and by the way.
And by the way, exactly, by the way. And he complained, he said that Mr. Darwin seems to think this is a great idea. To me, it was just obvious. Rather, as you said, Coleman, with hindsight. But and then he complained that Darwin had not mentioned him in the book, which is true. Darwin didn't know about him. And he complained, instead of complaining in a major book, he complained in a letter to the Gardener's Chronicle. So he wasn't exactly a great self-publicist. But anyway, the point is that all three of them lived in the 19th century, and nobody before that really got it. I mean, various people had got the idea of evolution, but not the idea of natural selection. It is an astonishingly powerful idea. I think if you could measure the power of a theory as a ratio of everything that it explains on the top of the line, and then what it needs to assume in order to do the explaining underneath, one divided by the other. And what natural selection explains is everything about life. It's a gigantic theory. It explains every single thing about life. And all it needs in order to do the explaining is really to assume heredity with occasional mistakes. That's it. And it's such a simple idea, that it's such a powerful idea, because the ratio of what it explains divided by what it needs to assume in order to do the explaining is such a colossal ratio. And I think maybe the reason nobody thought of it is that it just is so powerful that people couldn't believe that anything so simple could explain all of life. It had to be God. It had to be done by some creative intelligence. And so great minds like Newton, who could have thought of it, Galileo, who could have thought of it, Hume, who could have thought of it, just never gave it a second thought, never even got close to it.
I think there's some clue in the fact that all of your great and helpful explanations of evolution are metaphors, right? The selfish gene is a metaphor.
Yes.
This notion of the animal as a book about the past, as information about the past, is a metaphor. And, I think if evolution were very intuitive, I don't think you would so readily need to grasp for these metaphors to understand it.
Yes.
But when you get the metaphor, suddenly it becomes simple. And, economics can have that character. The invisible hand helps people understand supply and demand and so forth. But there's something about a slow, stepwise process that really shows its magic over the course of millions of years that is hard for people to wrap their head around.
Yes, especially as there are so many millions of years. It is such a very slow process. And I mean, one of the things that creationists say sort of is things like, well, when I see a monkey give birth to a human, I'll believe it. When they don't realize that it does take millions of years. So that's one barrier. Darwin very shrewdly went at it via domestication, because everybody was familiar with the idea that you can breed plants and animals by artificial selection. I mean, people know that dogs are all, well, perhaps they didn't know then that dogs came from wolves, but they knew that you could breed maize, corn. I mean, you knew you can breed cabbages. You know that you can breed roses by selecting each generation. And so the idea of non-random survival is already implanted in the minds of anybody who's familiar with agriculture, horticulture, pigeon breeding, dog breeding. And in a way, all that Darwin and Wallace did was to say, you don't need a breeder. You don't need a human breeder. Nature does the job for you. Survival, just plain survival does the job for you. And when you think that a Yorkshire Terrier or a poodle or a Pekingese are all wolves, and have they been transformed from a wolf into a Pekingese or a bulldog in a matter of a few centuries? Just think what you could do with hundreds of millions of years of non-random survival.
So a fact I found interesting and astounding from your book was you have two examples of this where you look at a selection pressure that is tiny, compounded over large periods of time. So you say something like, imagine a mouse that has a very small selection pressure to get bigger, which is to say bigger mice have a tiny advantage in terms of reproducing. So small that you wouldn't even notice it if you were studying at any point in time. But, we're talking about less than a 1% advantage in reproduction, right? But
yes,
you compound that over.
The point of this it's a hypothetical calculation. It was done by Ledyard Stebbins, an American botanist, actually. And he set the selection pressure. That means the advantage that a slightly larger mouse has over a smaller one. How much advantage does it have? He set it to be so small that you couldn't detect it if you were doing field work. Mm-hmm. Going out there, examining mice and collecting them, you wouldn't. It would be lost in the noise. You wouldn't detect it. It's too weak a selection pressure to be detectable in ecological field work, and yet it would take only such a short time for these mice to grow to the size of elephants that it would be beyond the reach of geologists to detect it. It would look instantaneous in the fossil record. It would be so fast. I forget the number of generations.
I think you said 20,000 generations.
20,000 generations. Well, a mouse generation is very short. It gets longer as they get larger and become more like elephants. But the point is that this kind of hypothetical calculation shows that even if the selection pressure is exceedingly weak, so weak you can't detect it in nature, it produces a gigantic effect, mouse to elephant, in such a quick time that it would not be detectable on the geological time scale. I find that a very disquieting thought. It's hypothetical, but it's a good calculation.
In your chapter on camouflage, you talk about left-right symmetry, right? We're all left-right symmetrical to some degree. Pretty much all animals are. I mean, all typical animals are. Yes. But you point out this is a disadvantage when it comes to camouflage because the tree bark you're trying to blend into is not symmetrical.
Yes.
So why are animals symmetrical?
I pose this as a puzzle. It seems to me to be that, as my dear friend John Maynard Smith occasionally said, natural selection has bungled again. It would seem that camouflage ought to be better And so often it's the symmetry that gives the game away. So often it's symmetry that betrays the animal. And actually the owl you mentioned is a good example of that, because when you look at this camouflaged owl, the photograph, you wouldn't notice it at all but for the symmetry. It's because it's symmetrical that you see it. And actually, this particular owl is winking with one eye. And I wondered whether this was trying to break this symmetry effect. And I think it's probably too fanciful, but it'd be rather a nice thought that natural selection builds in a tendency to shut one eye to so that the camouflage is not quite so easily broken.
So if you have, say, a butterfly that has false eyes on the wings that make it look like a different kind of animal, and you have 5 different competing explanations for what those eyes do evolutionarily, how do you decide between them?
Yeah, it's a slightly embarrassing question, because so often we are criticized for coming up with so-called just-so stories. Mm-hmm. Actually, Kipling's just-so stories are all Lamarckian. They're the inheritance of acquired characteristics. But it is very easy to come up with explanations post hoc with hindsight, mm-hmm. and that they're not easy to test. It is true that a large number of butterflies and moths have eye spots. Have spots on their wings that look like eyes. And that was actually worked on, I don't mention this in the book, but it was worked on by a man called David Blest. It looks as though they are scary. They're not camouflage. They're what the moth or butterfly does is suddenly expose the eye spots. And a would-be predator is startled by the sudden appearance of eyes looking like that. And so that gives that puts the predator off is the idea. I call it the Barbar effect. Do you know Barbar the elephant? When the elephants had a war against the rhinoceroses, you may remember Barbar had all the elephants paint great big eyes on their backsides and frighten the rhinoceroses off. That seems to be what's going on. There's a couple of photographs in the book of an octopus with magnificent false eyes. It's really, really scary. This octopus has this gigantic false eyes, which I would certainly be put off. And then there's another one next to it of a vulture, which has false eyes. The real eyes are small, and the false eyes are very startling, very, very scary. And in this case, it seems to be the vulture seems to be to scare other vultures away from a carcass when they're competing for a carcass. But eyes are scary. But your general question is a good one. How do you test it? How do you know? There are ways you can test hypotheses about natural selection. Let me try to think of one. Well, my old maestro Nico Tinbergen was interested in why it is that seagulls, remove the empty eggshells from the nest when the chicks have hatched. And he had about 5 hypotheses as to why they did this. Maybe the empty shells were breeding grounds for bacteria. So it was a good idea to get rid of the shells. Maybe the sharp edges would cut the chicks. But the hypothesis which he eventually demonstrated experimentally was that the empty eggshells attract predators. And the reason is that the eggs themselves, seagull eggs themselves, are beautifully camouflaged. They're grey, brown, mottled, speckled, and they very difficult to see from the air. But when the eggs hatch, the empty insides of the eggshells are white and conspicuous. And Tinbergen and his colleagues actually demonstrated experimentally by putting empty eggshells in nests that they did indeed attract predators. So you can do experiments of that sort, but in many cases it's pretty much intuitive.
Yeah. So there is also, one critique of evolutionary explanations or a confusion, which is the intermediate stage problem.
Oh, yes.
So, for instance, you show this snake in the book that whose tail, the end of its tail, looks like a spider.
Yes.
Right. And that's very useful because something will come try to eat the spider or whatever, and then the snake will get it. So I can perfectly well imagine why having a spider tail is awesome if you're a snake. But when I zoom back to the first snake that's just beginning it's hard for me to see how that's advantageous, right? So how does this work?
It's a great question. By the way, the snake, there's a photograph of it in the book, but you really need to see a film, because if you see the film of it, the tip of this, it's a snake from Iran, and the tip of the snake's tail, it weaves it around just like a spider, rushing around. It's uncannily like a spider, and it's got little feathery things that look like legs. And there's an actual film of a bird coming down, pecking at the spider, and then it's the last thing that bird does. And as you say, how does it get started? Because it's all very well once the perfection has finished. You've got to the end of the gradient of perfection. Mm-hmm. But how did it get started? And this applies really to all camouflaged animals, not just this snake, but all animals that survive because they resemble something else. Take, for example, a stick caterpillar or a stick insect, which looks like a stick. There's a picture in the book of a stick caterpillar standing sort of rigidly out from a branch. It looks just like a twig with little leaf scars on it and little bud scars on it and things, uncannily like a stick. But how did it get started? The answer, I'm almost sure, is this. The seeing conditions in which a predator encounters the ancestors of that caterpillar would have varied from very good light, full frontal view, which would have provided the final perfecting stages at the end of the evolutionary progression. Mm-hmm. The beginning of the evolutionary progression, when the ancestors of the stick caterpillar hardly look like a stick at all, but it's just a kind of long thing, then that would have fooled a predator if the predator was seeing the thing out of the corner of its eye, or from a distance, or in a poor light, or when it was attending to something else. So the original fumbling beginning stages of the evolutionary progression are provided by poor seeing conditions. And then there's a gradient of seeing conditions all the way up to the final perfecting stage. Intermediate seeing conditions, not very poor light, but slightly poor light, and then slightly better light. Not totally out of the corner of the eye, but sort of it's that sort of angle. There's a complete gradient. The same problem arises with the question that creationists often ask: what's the use of half a wing? It's all very well saying that a wing is great once it's perfected because you can fly with it, but how did it begin? And once again, you've got to think of a gradient of improvement, where the original stages would be something like, something like a squirrel jumping from branch to branch. And any little increase in surface area would increase the distance that the squirrel could jump from branch to branch. So without any flight surface at all, it could jump, say, 1 yard. And then with a slight flap of skin in the elbow, that might be able to jump 1.5 yards, and then with a slightly bigger flap of skin, 2 yards, and so on. And in the end, you get to a flying squirrel, so-called a flying squirrel, which is a squirrel that has a great big flap of skin stretching from the tip of the hand to the tip of the foot. And there are these flying squirrels, and they glide great distances, 100 yards with them. And you can see that you can easily imagine the progression from the start to the end of this. And that may be how bats got their start.
Right. And speaking of bats, in the book you say that bats might hear color.
Oh my.
Were you high when you wrote that, or is there...
Yeah, okay. Well, look, this is a favorite theory of mine. It's totally untestable, which in scientific circles is a no-no. Okay. Any animal, a visual animal like us, constructs a model in the head of the world in which it lives. And in the case of an insect hunting bird, like a swallow, for example, it must have a model in its head which is very good, well adapted to catching flying objects, flying insects. Whereas a mole, for example, would have a very different kind of world model, underground, total darkness, and so on. Well, bats move around and navigate by echoes, echolocation, sonar. They're pretty much blind, and they are exceedingly good at navigating, avoiding obstacles, and catching insects on the wing, flying very fast, using only echoes of their own cries. And these cries are ultrasonic. They're very, very high frequency, which they have to be in order to provide the resolution. Now, we know from experiments that the acuity of echolocation of bats is comparable to the acuity that any visual animal has. They can fly between wires that are just spaced enough for them to get through, and without hitting the wires. They can fly very fast. They can catch insects on the wing. Insects are taking avoiding tactics. So the bats must have a model in their head which is pretty much like the model that a visual animal like us or like a swallow has. It's just that the model is built up from echoes of sound rather than from the eyes. Mm-hmm. Okay, that's step one of the argument. Now, what about color? A visual animal like us or like a bird uses color, uses the hues that we perceive, like red and blue and green and yellow, as convenient labels for different wavelengths of light. And obviously, that's not directly applicable to bats because they don't see light at all. However, when bats went blind in evolution, their ancestors would have been visual animals. They would have had color vision, perhaps 2-color vision, not 3-color vision. Many mammals have 2-color vision, like colorblind people. But nevertheless, they would have had these internal brain labels, which were convenient internal brain labels for wavelengths of light. Red and blue would have been labels for different objects with different wavelengths of light. Now, when bats went blind, these internal brain labels would have been left with nothing to do. I mean, they were there in the brain, and ancestrally there in the brain. They were no longer useful to designate wavelength of light because bats had given up on light. Why not sequester them? Why not use them, commandeer them for echoes of different characteristics? For example, a hard, shiny surface might be designated by the label red, and a soft, furry surface like this carpet or like a soft moth might be designated by the label blue. It's totally a speculative theory, but I think it's plausible because why would the bat not make use of these internal labels when it went blind?
And the other part of it is we know it's possible to sort of to see sounds. We know it's possible to mix up these senses from synesthesia.
Yes, some people are synesthetic, but maybe everybody is to a small extent. But some people claim that they really do hear color. They really do, and I suppose I have to believe. Maybe there are some synesthetics in the audience here. Anybody claims to hear color or smell color, maybe. Yes, so it would be a kind of evolutionary commandeering of synesthesia.
Yeah. Okay, so I'm going to list some gripes with evolution's poor design. A common one, which, knock on wood, I have not suffered from yet, is lower back pain.
Yes.
Why are our backs so poorly built?
Yeah. Well, I think that probably the conventional answer is that we were never designed to walk upright. I mean, our mammal ancestors have been walking on all fours for hundreds of millions of years. And then quite suddenly, in the last 4 or 5 million years or so, our ancestors rose up on their hind legs. And our backs understandably protest at being pushed into.
And they've protested for 5 million years. That seems
it's a short time by evolutionary standards. Yeah. So yes, that's the kind of thing that is, I suppose, plausible but untestable.
What about pain from chronic illnesses that would have been incurable or are still incurable? So, I mean, for instance, cancer is still is incurable in some cases and certainly was.
Yeah.
Why do we feel pain
Why is it
if
painful?
we can't fix it?
Pain is a device put into the brain to deter animals from repeating actions which lead to damage. Mm-hmm. So it's easy to see why it's painful to prick yourself with a sharp implement or get pricked by somebody else with a sharp implement. It's easy to see why picking up a hot coal should be painful. It's a warning. Don't do that again. Don't repeat an action which leads to damage to the body, because damage to the body in nature could presage death and therefore failure to reproduce. So that's what pain is for. And therefore, Coleman, you raised the question, why would an internal cancer be painful? Because there's nothing you can do about it. It's not a warning of anything, because you cannot do anything. It's not like, don't pick up that coal again, or don't jump out of a tree again because you hurt yourself. You can't do anything about it. I think, I'm sorry to say, it's just that there was no evolutionary disadvantage to having internal pain. Natural selection doesn't care about our feelings. And
so it's like Ben Shapiro.
Yeah. It's. I mean, Darwin actually worried about this, how cruel it is. It is a very cruel process. But yes, that's a problem.
And it's especially cruel with anything that happens to people over the age of 30 or 40, as most of our ancestors probably would have been reproducing by 25. No?
The point is that because we tend to reproduce young, anything that happens after that is relatively irrelevant, evolutionarily speaking. And so this is sort of probably why senescence happens, why we decay in old age. It's because if you imagine that genes mature, have their effects at different stages, then any gene that, let's take cancer for example, any gene that gives you a genetic tendency to get cancer when you're 10 is pretty unlikely to get through to the next generation. Mm-hmm. A gene that gives you cancer when you're 60 has every chance of getting through to the next generation because you've already reproduced by then. And so the older you get, the more you are assailed by a kind of dustbin of genes that have got through the generations because of so many people of your ancestors that have reproduced before they got to that age.
Yeah. Okay. Next complaint. This is this is one I sadly do suffer from. Male pattern baldness. What is the evolutionary story there?
Some people think it's sexy. I don't know. There are all sorts of things about human facial features which are not obvious. I mean, why are we largely naked, but why do we have hair on the top of our heads and in certain other areas, and not anywhere else, or not much anywhere else? Why do we have eyebrows? There are also, why do we have beards? I mean, it's Darwin would have answered sexual selection. Darwin had two theories of evolution. One was natural selection and one was sexual selection. They're kind of different aspects of the same thing, but in sexual selection is all about competition within one sex for the other sex. And so something like beards could well be sexual selection, either perhaps intimidating other males, something of that sort. That's the kind of explanation that Darwin would have come up with. And as for male pattern baldness, I have no. I think even if I did have a hypothesis, it would be of no great interest because it's, as you were saying earlier, it's easy to just kind of toss them off.
Why don't fingers and limbs grow back when they're cut off? I mean, I know that sounds like a question I would ask after smoking too much weed. But what I'm getting at is if I cut my hand, the skin grows back. That's extraordinarily adaptive to have that ability.
Yes.
It would seem to me equally adaptive to be able to grow back bone if it's lost, to grow back fingers. Yes. And yet, over millions of years, we haven't adapted this. Why?
Well, you should be a newt. I mean, there are plenty of animals that do, and it's unfortunate that mammals don't, but newts do.
So, is that a case where the mutation never arose in the first place, or would it be too costly even if the mutation did arise in the gene pool?
Those are both excellent questions, and those are general questions that you can ask. Why don't anything evolve? Why don't pigs have wings? Why don't there are all sorts of things you could imagine. Mm-hmm. As you said, the kind of explanation, it might be that there never were the necessary mutations, or it was too costly, as you said. Mm-hmm. I agree with you that if we could have the regeneration capacities of a newt, it would be a very good thing. And I don't know why we don't. I don't know why mammals don't. I'm sorry about that.
It's your fault.
Yes.
Okay, so you spend time talking about pseudogenes in the book, which is a very interesting phenomenon, and you talk about the sense of smell we don't have. Can you describe what pseudogenes are and why they matter?
Yes. Genes, as you know, are DNA programs for making proteins. So there is a strict genetic code whereby triplets of code letters in DNA are coded into amino acids, which are the building blocks of proteins. And nowadays, these can all be read. It's an astonishing fact that the genome of any animal can now be read. You could either read it as DNA or read it as protein. There are many, many genes in the genome which once upon a time must have coded for protein, but no longer do, are no longer read. These are pseudogenes, and they have the information there to code for protein, but it's just that they're not read. And they're a big headache for creationists, because why on earth would the Almighty have put in these vestiges of genes that don't do anything but could do something if only they were read? And you mentioned sense of smell, which is a beautiful example, which I learned from Jerry Coyne's book, Why Evolution is True. As you know, the human sense of smell is very poor compared to that of many mammals, like dogs. But it's an astonishing fact that we have the genes to do it. But they're pseudogenes. They're not read. They're not decoded. So they once upon a time they would have been, and they've, rather than when we lost our sense of smell, or our very good sense of smell, instead of losing the genes altogether, they was just simply ignored. And by the way, that's what happens on computer disks as well. If you think you've erased some incriminating piece of information from your hard disk, you probably haven't erased it. It's still there. All that's happened is that the system has been told to reuse that area of the disk if necessary. So it's just that the label pointing to that document that you think you've erased has been erased, but the document is actually still sitting there. And that is exactly like a pseudogene.
So do genes become pseudogenes by natural selection or by some other process?
Well, in the sense that I suppose you could call it natural selection. If it's no longer necessary to use a particular gene, then rather than get rid of it, it's simply not used.
So when we have, this is different than when we have like a vestigial organ like an appendix, because we're still, cells are still turning into appendices.
Yeah, right? Yes, it is. It's sort
so
of.
Why don't we turn off the appendix?
Kind of genetic equivalent of an appendix,
Yeah.
I suppose you could say. Actually, appendixes are not necessarily totally useless, but anyway.
sorry.
But I know what you mean. Vestigial organs, yes.
Okay, so this is a question that I encountered in, I think, Matt Ridley's book. I think it was the Red Queen. It's been a while, but the logic of natural selection does not necessitate sexual reproduction, right? It could work just as well for us to split asexually.
Well, in a way, twice as well. Yeah,
right,
yes,
and
yes.
it would make more sense in a way. It's simpler because we're not scrambling and playing, rolling the dice with someone else's genetics and,
That's right.
and
Yes.
all that. So not that I'm angry about sexual reproduction, I actually quite like it, but but I don't understand it from an evolutionary point of view. Why do we do that?
Well, join the club. I mean, it is one of the great puzzles. It's not a total puzzle. I mean, there's plenty of progress being made towards it, but lots of books are written about it. On the face of it, there shouldn't be any males.
So have the feminists got to you, Richard?
A female who reproduces clonally, who produces a clone of herself, passes on 100% of her genes, whereas a female who reproduces sexually passes only half of her genes to each offspring. And in a species like a pheasant or a peacock, where males don't do any work, but just contribute sperm, and all the work is done by females, the pressure on females to dispense with males would seem to be great, because 100% of their genes get passed on to the next generation. Whereas actually in pheasants and etc., only 50% get passed on. Well, that so-called cost of sex or cost of males doesn't apply in those species where males do some work. In those species where males assist in rearing the young, where a couple can rear twice as many babies as a female on her own, the cost of sex is wiped out. In such species, sex makes sense, but there are many species where the male doesn't do any work, and so the cost of sex rears its head, and you are left wondering why we have sex at all, why they have sex at all, why there are any males. And lots of books have been written about it. There are various theories about it. If you look at the distribution in the animal kingdom of asexual reproduction, there are cases where females just produce clones of themselves. Aphids do it, stick insects do it. There is a lizard species where in particular valleys, there are nothing but females reproducing clonally. And if you look at the distribution of asexual reproduction, you draw a great big tree of the animal kingdom, a huge great tree, and you color in where there is asexual reproduction, these little tips of twigs here and there and there and there and there and there and there. It's not a great big branch like the whole of the arthropods or the whole of the mollusk or something of that sort. It's always just little tips of twigs in the tree of life. And that suggests to you, of course, that what happens is that asexual reproduction occasionally arises and goes extinct before the tree has had a chance to produce more than just a twig. So it looks as though there does seem to be some disadvantages. Maybe the asexual species are vulnerable to parasites, is one very fashionable theory. Anyway, as I say, it's a lively area of thought and research.
Why are teeth so bad? I mean, like prior to flossing, brushing, braces, teeth pretty much sucked. I mean,
I once asked my dentist that.
Especially British teeth.
Afraid that's true. I once asked my dentist, Mr. Sharp. That was before I went to Mr. Pick. And I said to Mr. Sharp, "Why are people wrong?" And he said, "Have you ever thought of the muck you eat?" And I think it's partly, I mean, what he meant was we eat too much sugar and that sort of thing. Our teeth are the only part of the skeleton which is actually exposed to the elements, exposed to the world, and exposed to sugar and other things which are bad. So yes, I mean, I don't have probably there are dentists in the audience who can answer that question.
Sugar would be far more abundant in our modern environment than it would have been.
Exactly. I mean, in our wild ancestors, sugar would have been extremely scarce, and we would have craved it. I mean, when a hunter-gatherer today finds a bee nest, they go wild for it, and they don't seem to mind getting stung. It's worth it.
So, speaking of the diet of our ancestors, you spend time in the book talking about how, just in the same way that an animal's camouflage is a kind of mirror image of its environment, our digestive system, a species' digestive system, is an image of the food that it ate.
Yes.
So, does our ancestral diet tell us anything useful about what we should and shouldn't be eating now, or are they just separate questions?
Well, first of all, I mean, it's a very perceptive point that the guts of an animal are a mirror, as you say, it's a very beautiful example of what I'm talking about. And a herbivore tends to have an enormously long gut and a great big throughput of plasma flowing like a great river through it, whereas a carnivore eats much less and has a much smaller gut. And if you look at our gut, we're omnivores. We are meat eaters and plant eaters as well. There's a very interesting book by Richard Wrangham about cooking. He thinks that the invention of cooking, the discovery of fire and then cooking, was a major watershed in human evolution, and he thinks it is maybe the key to why our brain got so big, that it was possible to cooking made it possible to get a much richer source of food and use it more efficiently. So yes, I mean, if you're asking, does our gut tell us what kind of a diet we primitively evolved to have? Yes, we're omnivores.
So we're fast approaching a world where, I mean, and I've spoken to people that are starting companies like this that use genome-wide association studies to predict the traits that different embryos will have and choose and eventually even tinker with the traits that a couple wants in their baby. A couple will say, I want my baby to be 6'2", I want them to be smarter, and so on and so forth. Do you give much thought to the implications of that technology?
It's politically dynamite because it's got the name eugenics tied to it, which is because of Hitler and that kind of horrible ideology where government controlled, government dictated breeding programs, breeding for tall, blonde, blue-eyed Nordic, types. So you have to sort of pick your words carefully when you talk about this because of eugenics. What you're talking about is not government-imposed eugenic aspiration, but personal. As you say, I want my child to be a great musician or something of that sort. And I think it will become possible, and people object to things like it'll be a toy of the rich, and only if some people will be able to do it. And you could buy your way into. You could buy a child, which has great mathematical ability or great athletic ability or whatever you want. You want. I didn't know. I mean, you're telling me that the people in Silicon Valley are already doing this?
I've spoken to people in the past 1 or 2 years that credibly say it's already possible, they've already done it, and it's just a matter of regulation and rollout and cost at this point.
Yes. Well, once you know which genes you want to foster, then I suppose the way to do it would be with IVF, in vitro fertilization, where at present, when you do IVF, you get the woman to superovulate. So you get say 10 eggs, and you have them all in a dish, and you fertilize them, and then you choose one. At random.
Or sometimes they choose just the biggest because.
Yes, that's right. Something like that.
Well, that's a signal of health.
But usually it's probably just choose pretty much amounts to choosing at random.
Right.
And in the case where you know that there's a lethal or sublethal gene there, if you know that there's hemophilia, for example. If you let the embryos develop to the 8-cell stage, they go 2, 4, 8, then it's possible to remove one cell without damaging the embryo and analyze the genes of that one cell. And there you know, okay, half of these in the Petri dish are carriers of hemophilia and half are not. And we're going to pick one of the ones that doesn't have it. Obviously better than picking at random. Well, that technique, no, I think nobody would really, very few people would object to doing that for something like haemophilia. But then if it was possible to say some of these are better athletes than others, or better musicians than others, or better mathematicians than others, then people start getting uneasy. But the method, I suppose, would work.
I mean, it seems strange to me, though, that people will spend, $30,000 a year sending their kids to private school on the assumption and the hope that it makes the kids smarter.
Yes.
But wouldn't choose the smartest of their 10 embryos right at the start.
You're so logical. I mean, that's right.
And I'm not sure who it hurts.
Yes, it's
if it's all voluntary.
It's you. If you have ambition that your child will be a musician, then you force the child to practice scales. Why not give it musical genes in the first place?
Right.
Yes.
Right. Anyway, okay. So, last question here. Another. I think issue that is becoming a very serious issue of concern all across the world is the decline of birth rates in developed countries, from America to nearly every country in Europe. It's severe in China, Japan, and South Korea. Populations are not at replacement level. Aside from certain, usually religious, very tight-knit religious communities, like, ultra-Orthodox Jews, Amish in America, and so forth. And people like Eric Kaufman have extrapolated this trend into the future and argued that, one of the implications of this, it seems to me, is that if there are any genes that select for, being more likely to belong to a high birth rate conservative religious group, those genes may outcompete the kind of secular liberal culture that I come from mightily in the next 100 years and change the course of democracies and so forth. Is that something you give any thought to?
Well, I don't think you need to bring genes in. You can do that sinister calculation just on memes alone, can't you?
Right.
You can say if there are certain religious beliefs which foster high birth rate, then those beliefs themselves become have a strong selection, non-genetic selection, in favor. You don't really need to bring genes in at all in order to make that calculation.
Yeah, but this has profound implication. Israel is perhaps the canary in the coal mine, because when Israel was founded, a tiny portion of its population was ultra-Orthodox. Now it's like something like 30+% just by birth rate increase alone, and that's had a huge rightward effect on its politics.
Yes. I hadn't thought of that, but yes, that's interesting.
Yeah. Okay, so we're going to go to audience questions now. We've got about 30 minutes, and hopefully if you wanted to ask a question, you were able to write them down on an index card. And I have the index cards here. Thank you very much. Okay.
Well, thank you
for the water. Okay. Professor Dawkins, what do you think humans will look like well into the future as evolution continues to shape us?
Well, if you look into the past, say you look 3 million years into the past, our ancestors then were Australopithecine. They would have been rather small, walking upright, with a rather small brain by our standards, about the size of a chimpanzee's brain. So the dominant trend over the last 3 million years has been an increase in brain size. We were already standing on our hind legs 3 million years ago, increase in brain size. So there's been a trend towards increasing brain size. Will that continue? And if it does, 3 million years hence, 3 million years into the future, will we have great big brains like the Mekong? In order for that to happen, there has to be a selection pressure in favor of big brains, which means that the largest-brained individuals have more children than the smaller-brained individuals. Whatever the selection pressure was that increased our brain size, nobody knows what that was, but presumably it has something to do with intelligence, with ability, with memory, perhaps, with intellectual ability. There must have been a selection pressure in favor of intellectual ability. And it must have been the case that the most intelligent individuals, if we're using that as our marker for brain size, the most intelligent individuals had the most children. That has to be going on for the next 3 million years. It has to be going on now in order for us to think that brain size will go on increasing. And there's no evidence at all. As we were just reflecting on just now. I think it's a very difficult thing to predict. I suppose another way of looking at it would be to say, in order for there to be an evolutionary change over that sort of time scale, it has to be the case that there is some kind of selection pressure going on, which is consistent for some millions of years, favoring certain genetic types as increasing reproductive rates over others. So, for example, if you ask the question, is there a tendency are some people being born because their parents are incompetent in the use of contraceptive? Is there any genetic tendency to be incompetent in fumbling in the use of contraception? Therefore, do we have an evolutionary trend towards incompetence in this particular regard, or incompetence generally? I mean, you see the problem. It's whatever selection pressure you think of in humans, it's not going to be the same thing for 1 million years, because look at the sort of environment we now live in. It's entirely governed by, influenced by culture, by technology, by changing circumstances. It's very hard to see what sort of trend there could be lasting millions of years if technology goes on the way it is. So I think it's probably fair to say that that cultural evolution, which is non-genetic, is by far the more important kind of evolution that's going on at present, and nobody would, but a fool really, would try to predict what we'll look like in 3 million years' time, except to say that, like most other species, will probably be extinct.
Okay. It seems like the feelings of the religious always have to be taken into consideration. Why do you think those who are critical of religion are bound by respectability politics?
Well, because we're too nice. There is a tendency for those who are not religious to be ultra respectful of those who are, and to zip their mouths and not say what they really think. So I think that's my rather flippant answer. But I think it's also true that the non-religious, perhaps especially in America, don't have the sort of lobbying power that the religious do. And politicians are forever bending over backwards to appease this lobby and that lobby and the other lobby. But so many of these are religious lobbies, and the non-religious don't seem to have a lobby. And therefore they don't exert an influence proportionate to their numbers, which are actually quite substantial and growing.
So you've said you're a cultural Christian. I'm quoting the question. I assume you're still an atheist. How sure are you that there's no God? These are kind of separate points, but
Yes. Well, I did say that I'm a cultural Christian in a broadcast in Britain a few months ago, and it seemed to surprise people who listen because, I mean, of course I'm a cultural Christian. I've brought up in a Christian society and brought up with knowing the Bible and knowing hymns and things like that. So it's no big deal to say one's a cultural Christian. It would be very difficult not to be. But of course I'm an atheist. And you could be a cultural Christian without believing in all that nonsense that they believe. Oh, and
how sure are you that there's no God?
Well, you can't be totally sure of a negative, but there are all sorts of things which you cannot be sure of in that sense, and so I think it's rather like saying, "How sure are you that there are no fairies and leprechauns and unicorns and things?" It's in that category that unless there is positive evidence for fairies, leprechauns, and gods, and Zeus and Jupiter and Thor, and Lord Mithras and Lord Krishna and so on, then there's no reason to believe them. And we have a scientific worldview which we're working on and which explains a lot, and what it doesn't explain, which is plenty, we're working on.
Is there hope for the achievement of a secular society? Do you think it is reachable within our lifetime?
There's a difference between hope and expectation. Obviously, I hope so. My lifetime's shorter than yours, but I think it's a very long-term hope. I love a scientific worldview. I think that there's something wonderful in the scientific understanding of why we exist and where we exist and what it's all for. And there's something so beautiful about that is if people become acquainted, become educated in scientific rationalism, the superstition and religion should all fall away. But we're a very long way from that, unfortunately.
Okay, this comes from someone who says they are running for office in Texas at 28, same age as me. Congratulations. Well, that might be premature, but I hope you win. If you're here, then I hope you win. Okay. In an age where misinformation about science abounds, including about evolution, what strategies do you think are most effective for scientists and normal people to counteract pseudoscience and promote scientific literacy?
I've spent my life trying to promote scientific literacy, and I'm not sure how successful I've been. I'm not terribly good at it where it comes to, I'm told I'm not very good at it where it comes to people who are religiously convinced of the opposite. I tend to, I've been criticized, for example, by Neil deGrasse Tyson and others in the nicest possible way for just, as he says, putting it out there and not indulging in any kind of act of persuasion or seduction. I think it's just so beautiful that if you understand it, that should be all it takes, but apparently that's not the case. In my own field of evolution education, I am somewhat unpopular with my colleagues because they wish to, I think I can use the word seduce, the religious people by telling them it's perfectly okay to be religious and be an evolutionist at the same time. An illustration of this, I was talking to one of the lawyers who was on our side in that famous case in, I think it was Pennsylvania, about science education. And after talking to me for a while, this lawyer said, "Well, thank goodness we didn't call you as an expert witness." Because I tend not to go along with yes, you can have God and evolution. I rather think they're incompatible, which it doesn't go down well with my colleagues who are trying to, very laudably, trying to increase the sum total of correct biological education. So I just tend to tell it like it is, and because I think that like it is wonderful, but that it's possible that a better strategy is to do it in a more seductive way and to enlist the support of religious scientists, which are valuable.
Are there ethical boundaries that you believe should be respected as we gain more control over genetic engineering?
As need to be respected, presumably. Does it say?
That you believe should be respected.
Should be respected, yes. Well, I'm sure there are, yes. I mean, we do have to be very, very careful. I think the precautionary principle is something that we need to take account of. And, well, it came up a while ago over the eugenic selection of designer babies, as they're called.
Yeah.
And of course, science can be misused, and physics can be misused terribly in the form of terrible weapons, and biology can too, because biology can be used to produce dreadful weapons, turning viruses against us and so on. So yes, of course there are ethical considerations.
If you could sit down with Christopher Hitchens today, what's the first thing you'd say to him?
How much we miss you. We miss his eloquence, his wonderful resonant voice, his ability to put down stupidity. He had extraordinary knowledge, erudition, and ability to think quickly on his feet, very enviable. He wasn't right about everything, but he was a wonderful person to have in your corner. I think I once said, if you're invited to have a debate against Christopher Hitchens, decline.
The first thing I would tell him is Donald Trump won the presidency of the United States, and then I would bring my phone to film his reaction, which would probably be an eloquent,
disbelief, I would have thought.
Yeah, disbelief, and then hitch slap for the generations. Okay. Any advice for what society can use instead of religion to promote community and citizenship?
Yes, well, there are just so many things you can do together, and togetherness is wonderful. You don't need to have a supernatural belief in order to get together and do things. I don't have any particular suggestions. They're just, humans we are a social species. We do things together. We like being together. We go to concerts and football matches and things, and we have human love, human affection. All these things are wonderful, and why drag in a lot of supernatural nonsense you don't need?
So, but pushing on that question a bit further, it's been many decades in America that, as you say, a growing portion of the population is secular. I think probably most of the people I grew up with in northern Jersey were not believers, probably the majority. But they're, secular institutions that are similar to church, but without all the bad stuff, haven't really arisen in my experience. In other words, I can imagine a secular church where you do all the good stuff, like reflect on what you're thankful for, talk about wise ways of living and living unselfishly, but you just don't have the God bits.
Yes, you could have,
but they don't really exist.
Moral discussions, ethical discussions. Yes,
I think a lot of people want that, but they don't really exist. I mean, they exist to an extent, but you have to search far and wide to find them. They don't have the staying power of your local church, which has been there for 50 years and blah, yada yada yada. What explains what I would consider the sort of failure of secular society to develop that alternative?
Yes, it's a good question, and I mean we can have occasions like this, and we can have book clubs and so on, but actual ethical discussions about secular morality would be important, and there's no reason why they shouldn't be organized, I suppose.
Mm-hmm. Okay, this is again from the woman who's running for State House in Texas. Okay, so she's hardworking Texans, and her name is Avery. I think that's how you pronounce it. Okay. In today's polarized political climate, do you believe that reason and science can help bridge divisiveness, or are we facing an era where facts are just sidelined in favor of ideology?
I'm sorry to say we are, yes. I mean, there's a horrible tendency to sideline. Sideline's putting it mildly. Facts are actively despised in some quarters, and there are politicians active in this country who make a hobby of denigrating facts and telling flat-out lies. And you know who I'm talking about.
Okay, I'm only just reading this question. I'm not totally sure I understand it. I think there's a point to it. How do you differentiate a scientific piece of data that falsifies a theory from a scientific piece of data that expands a theory? For example, why would finding a fossil in the wrong column? I don't think that's...
Yes.
Why would that potentially falsify evolution, but not finding out an organism is more complex than initially thought? Does that make sense to you, or do you know what it's getting at? There's almost something that makes sense to me in there.
How do you differentiate? Okay. Why would finding a fossil in the wrong column potentially falsify evolution, but not finding out an organism, that an organism is more complex than initially thought? I don't actually understand it. Finding a fossil in the wrong column, in the wrong place in the fossil record, when J.B.S. Haldane was asked what could falsify evolution, falsification is something very popular among philosophers of science, as you probably know. And he was challenged to say what would falsify evolution, and he said fossil rabbits in the Precambrian. And that, I guess that's the kind of thing the questioner is referring to. If you did find a fossil rabbit in the Precambrian, which was genuine, I mean, it would be quite hard to... You would have to really dig around and make sure that it hadn't been planted there. But it would have to be genuine. That would falsify evolution. But not finding out an organism is more complex than initially thought.
Yeah, that's a bit...
I'm afraid I don't get that. I apologize. It's probably my fault.
Let's move on. So, what would you say to young people today who might be interested in reading The Origin of Species by Darwin? Why is it still relevant today?
It's a beautifully written book. It's a Victorian book. It's written in the 19th century, so the sentences are rather long, and commas are in a different place from where you'd put them in modern English. I'm not quite sure why that is. I actually had the honor of reading The Origin of Species for the audio book produced by one publisher, and it was a great experience for me. I had to, I didn't attempt to sort of impersonate Darwin. I read it in my own voice, but it was a challenge I had to make sure I understood every single sentence before I read it. And what impresses me about reading Darwin is that he really, really wants to be understood. He would have absolutely no time for the kind of intellectual who attempts to gain prestige by being incomprehensible. Mm-hmm. And I fear there are quite a few of those. I'm trying to remember, I formulated Dawkins's law of academic difficulty, which is something like this. Obscurantism in an academic discipline expands to fill the vacuum of its intrinsic simplicity. Physics is genuinely difficult, and so physicists who try to make it simple are doing a great job. Mm-hmm. There are other subjects which actually have no content at all, and therefore their protagonists will sometimes language it up to make it sound profound when there is no profundity there. Mm-hmm. And Darwin is the opposite of that. Darwin really, really wanted to be understood, and he labored at being understood. And so if you will read him, it's worth it. It repays the effort. He's as Michael Gieselin has said, he was working sometimes 100 years ahead of his time. He was an astonishingly perceptive writer and thinker.
Is the biological cooperation exhibited in Homo sapiens relations more influenced by genetics, self-domestication, or culture?
Well, I think a bit of all. We are a pretty social species. We cooperate a great deal. We depend upon, our culture is based upon mutual cooperation in the sense that almost none of us could survive without each other. I mean, we couldn't actually survive without going to the grocery store and having our food wrapped up for us by others. And we have electricity supplied for us, water supplied for us, and so on. So we are very, very dependent upon cultural, what society provides for us. So I can't really give a comparative answer to that question. We are a very dependent species, mutually dependent.
Since you have arrived in Texas, this is a funny one. Since you've arrived in Texas, has anyone tried to persuade you to believe in God?
Rather to my regret, no.
No, but we have been persuaded to eat barbecue within 5 minutes of getting backstage. Through which you might see God, because I'm told it's that good. Okay, is morality the outcome of culture or evolution? Could future evolutionary pressures lead to changes in what we consider to be moral behavior?
I think it's rather interesting how morality evolves culturally. I think if you look back, you don't have to look very far back, actually, to see really major changes cultural changes in what was considered to be moral. If you look back to the time of Darwin, for example, Darwin and his friends were in the vanguard of advanced liberal thought. I mean, Darwin was passionately against slavery, for example, and so was Huxley, his friend. But if you actually read what people like Huxley said and what people like Darwin said, and Abraham Lincoln, also obviously in the vanguard of progressive liberal thought, by today's standards, it's shocking. Just about everybody in Victorian England was a racist, and by modern standards. And so there seems to be no doubt that morality does evolve culturally and evolve very fast culturally, but it no doubt has a basis in biological evolution, because as I said several times this evening, we are a social species, and we depend upon reciprocation, upon mutualism, mutual help. And so we have probably built into us genetically tendencies to feel obligation to one another, feelings of debt, guilt, of favors owed to people who've done favors to us, and so on. So that feeds in. But I think cultural evolution of morality does change astonishingly rapidly, and it changes by the century, even by the decade.
How do you see the role of randomness in shaping life as we know it? Could there be hidden patterns or rules in what we perceive as random?
Well, randomness in evolution comes in the form of random mutation. Mutation is random genetic change, and it's that the genetic differences due to mutation that natural selection acts upon. It's only random in the sense that it's not guided towards improvement. The improvement all comes afterwards in the form of non-random selection. But mutation is non-random in other senses. It can be induced by radioactivity, for example, with certain chemical mutagens. So in that sense, it's non-random. If you look at the major patterns of evolution, what goes extinct and what doesn't go extinct, there's probably a fair bit of randomness there, a fair bit of just plain luck. The dinosaurs went extinct as a matter of sheer bad luck. The Earth was hit by a huge meteorite, and virtually nothing survived, and the dinosaurs all went extinct except birds. So that was a sort of random piece of terrible bad luck on the dinosaurs. So there's that kind of randomness. I'm not quite sure what the question is getting at, but I'm rambling away.
Okay, so before the last question, I just want to remind everyone, if you have a VIP ticket for the meet and greet, stay in your seats, and a bit after we're done, the producer will come out and get you to go do the book signing and meet and greet with Richard. So if you have the VIP, just stay where you are after the event, and we'll give you directions, and if you don't, you'll be free to go home in a moment. So with that, let's get to the last audience question. With this being your swan song tour, how do you wish to be remembered?
I would like to be remembered as a lover of science, a lover of truth, and somebody who tried to impart that love to other people. Carl Sagan said, when you're in love, you want to tell the world. And he was in love with science and tried to tell the world. I'd like to be remembered as trying to do the same thing.
Okay, please join me in thanking Richard Dawkins.
Thank you so much. This is terrific.